Hey Dr. Lane, this is my video reassessment for chapter 22. The question asks, or says, as a coil of N2 turns and has a radius of R2 placed at the origin, and the second coil of radius R1 with a number of turns N1 carrying a current I1 is placed at a distance x from the first coil. And so ultimately I would like to know the magnitude of the current in the first coil. So to find the magnetic field produced by the second coil at distance x along the axis is approximately equal to N1 times mu naught over 4 pi times 2I1 pi r squared over x cubed, as long as x is much greater than r. Then the magnetic flux is N2B1 times pi r squared of the second radius. That can be rewritten like I have here. The EMF induced by the first coil is given here, which can also be written like this. And as the current goes through the coil, it remains constant, but the second coil is moving with a speed, which I have given v as the variable, towards the first coil along the x-axis, which is where these two equations come in. And since the speed is given by dx over dt, the current through the coil is given by this equation here. And the expression for current can be written like this. So I have N1, N2 mu naught over 4 pi times 2I1 pi r squared of the first one, pi r squared of the second one, times 3 volts, or 3 times velocity, and that's over 4 x to the 4th power times r. So the observation location is 1500 centimeters, and the source location is 000 centimeters. So they are 1500 centimeters apart. The magnitude of this is going to be 15 centimeters, which is here. Then basically I just plugged everything into my equation, and I got that the magnitude of current in the first coil is going to be 1.34 times 10 to the negative 6 amps.